Alright, hello everyone. My name is Chris Hickson. I'm a student teacher at Miles ELC in the middle school for mathematics. This is my second video, and the topic we're going to be going over today is proportional relationships, proportional rates. This lesson was presented on January 11th, 2017. So as you can see, here's our agenda. This is the first slide that your students saw. This is our monthly outlook. This is a calendar of things that are going to be coming up. As you can see, the meow is a meow quiz. It's a math end of week quiz. So now we'll get into the class notes for the lesson. So as you can see, we've got two different situations where we will be identifying proportional relationships. And the first situation is on a graph. If a relationship is proportional, its graph will be a straight line and pass through the origin. So in order for us to determine if a graph is proportional or not, it must be a straight line and it must pass through the origin. Now, you may be unfamiliar with the word origin, and that's alright. So let's go ahead and recap what an origin is. So recall that we've got a y-axis and an x-axis. The x-axis is horizontally while the y-axis is the one going vertically. Now remember that in order to be proportional, our graph must pass through the origin. The origin is located right here where the x and y axes cross. So our line must cross through not quite as straight of a line as I wanted, so let me just redo this entire thing. Try to make it a little more clear. So there is our origin, highlighted in green. And the red line is an example of a line that is straight. Well, not straight because I can't draw very well, but it's supposed to be straight and it passes through the origin. Therefore, this is an example of a proportional relationship. So, the next thing we're going to be talking about is proportional relationships in tables. Now, in a table, the relationship will be shown as a constant rate of change, increasing or decreasing by the same value all the time. So recall what our tables look like. This is an example of a table we might be given to determine whether or not it is proportional. So we've set up our table. So in order to determine whether or not it's a proportional relationship, we must determine the rate of change for each one of these sets. And by determining the rate of change for each one of the sets, if they are the same, then we can determine that it is a constant rate of change, which qualifies the table to be proportional. Now, in order to determine whether these the rate of change of the pairs, we must calculate the rate of change. And in order to do that, we must divide our y value by our x value. So now all we're going to do is substitute our first y value in for y and our first x value in for x. So for y we've got 3, for x we've got 1. 3 divided by 1 is 3. So the rate of change for the first part, or for the first pair, is 3. So again, recall what I said earlier, that in order to determine whether or not this table is proportional, we must calculate the rate of change for all of the pairs, and they must all be equal to 3, because that is what we determined was the rate of change for the first pair. I'll go ahead and leave the y over x here just to help us remember what we need to do. So the next thing we need to do is determine the rate of change for our next pair, which is 6 and 2. So we substitute 6 in for y and 2 in for x and divide. 6 divided by 2 is also 3. So notice it's the same as the first pair, and this is important because so far we're 2/3 of the way of determining that this is a proportional relationship. But we're not done yet. We do have one more pair left just to confirm. So for the third pair, 9 and 3, we substitute 9 in for y and 3 in for x. 9 divided by 3 is also 3. So you'll notice that for each one of our pairs we divided them to find the rate of change, and each time the rate of change was 3. 3 divided by 1 is 3, 6 divided by 2 is 3, and 9 divided by 3 is 3. Because these are the same, we can decide, or we can confirm, that 3 is our constant rate of change. And because it has a constant rate of change, it is in fact a proportional relationship. So this slide was put in here because it is another definition for determining proportional relationships, but it's not one that we're going to go into great detail with for this presentation, for this lesson. But it says the written description in words or in equation form, there is a constant rate of change. But if you remember back to the previous slide we just did, we determined that our constant rate of change was 3. So we've already found our constant rate of change. We just did that in our example. Now this will mean that eventually we'll be able to set up equations, or English or word problems of our own, or English explanations of our proportional relationship. An example of this in the example we just did is that for every x value we had, we were multiplying it by 3 to get our y value. So what I mean by that is if we set up our table, we can substitute our x values, and I'll go ahead and show you what I mean. So if we take the table we had before and just plug in the x values, let's say we only knew the x values. For each one of those x values, if we substitute them in for the blue x, we should be able to use our constant rate of change to determine our y value. So our first x value is 1, and we're going to go ahead and throw that into our equation in place of the blue x. So when you do 3 times 1, you're going to get 3, which is also the y value that we had before. Now we'll do the same thing for 2. Substitute the 2 in for the x. 2 times 3 is 6. And again for the 3. 3 times 3 is 9. So you'll notice that this is the same table we had before. That's because our constant rate of change was the same, or 3, and we used the same x values we had on the table before. So we can again determine that our constant rate of change is 3. This is also sometimes referred to as the constant of proportionality. Again, that's constant of proportionality. So now we're going to get into the first example we did. We have to determine whether or not this is a proportional relationship. And we must explain how we know. Well, this is a graph, and so let's go back. Well, we'll first draw our graph here. So it looks something like this. So let's go back and look at what a graph must do in order to be proportional. So if you look in the first sentence, if a relationship is proportional, its graph will be a straight line and pass through the origin. Well, this is a straight line. I mean, my handwriting's not the best, but it's supposed to be a straight line. And the next part requires it to pass through the origin. Now, let's again recall what origin means. Our origin is right here. It's where our x and y axes meet, right at that little corner. But you'll notice our line does not go through the origin. Therefore, we cannot determine that this is proportional. This is not a proportional relationship. In our next example, we have a table. So we just did an example about a table, and we figured out whether or not it was proportional. So remember that for each set of numbers, we have to determine its rate of change. So this one has dogs and paws, but for simplicity's sake, we're going to switch out dogs for x and change paws to y. So we'll rewrite this table with x's and y's instead of dogs and paws. So we've set up our table, but now we have to figure out the rate of change for each one of these pairs. So remember, in order to do that, in order to determine the rate of change, we must divide our y value by our x value, or paws divided by dogs. So again, we've got 3 different pairs, so we'll have to set up 3 different rates of change. So we'll substitute in the first one. Our first pair, 2 and 8. We'll substitute the 8 in for y and the 2 in for x, and 8 divided by 2 is 4. I'm going to go ahead and rewrite this and give us a little bit more space. My dog made some noise. He was kind of acting crazy back there. That's Jax. That's my dog. So now we'll do the same thing for the second pair. So we'll substitute 16 in for y in the numerator and 4 in for x in the denominator. 16 divided by 4 is also 4. So we're going to do the same thing again for our next pair, 6 and 24. We'll substitute 24 in for y and 6 in for x. 24 divided by 6 is also 4. Alright, so each one of our rates of change is 4. That means we can determine that it is a constant rate of change, or a constant of proportionality. That means that we can determine that this table about dogs and paws is in fact proportional. So in this example, this is also a table, and we have to determine whether or not it's proportional. So again, in order to figure out whether or not a table is proportional, we need to figure out the rate of change for each one of these pairs and ensure that it is a constant rate of change. In order to do that, we must divide the y by the x value. So for our first pair is 9 and 3. So we'll substitute 9 in for y and 3 in for x. 9 divided by 3 is what? That's right, 9 divided by 3 is 3. So I'm going to go ahead and write this off to the side, and we'll just remember that the first rate of change we got was 3. Now the next pair is 16 and 4. So we'll substitute 16 in for y and 4 for x, and determine our next rate of change. 16 divided by 4 is 4. Okay, well we'll write that down, and we'll go ahead and do the next one and just kind of try to see what's going on here. So our next pair is 25 over 5. So we'll substitute 25 in for y and 5 in for x. 25 divided by 5 is 5. So we got rates of 3, 4, and 5. These rates are not continuous. They're not constant. These rates change. They're going. The rate is increasing. But in order for our table to have a relationship, it must have a constant rate of change. But ours is not constant. If it were 3 and 3 and 3, or 4 and 4 and 4, or 5 and 5 and 5, it would be constant. But in this case, our rate of change is changing. Therefore, no, this is not a proportional relationship. And that was it. At this point, I handed out the homework to the students. The homework was a one-page double-sided homework sheet that had approximately 6 questions on it. 4 were to determine the proportionality of a graph or a table, and the last 2 questions required the students to come up with their own table and graph that was proportional. So anyway, that's it for this lesson. Thanks again. If you got any questions or any comments, please feel free to leave them on YouTube. The next video we'll be talking about, or the next class period, we'll be talking about this same stuff more in depth, and we'll be talking about forming equations based on proportional relationships. So again, if you've got any comments or questions, please feel free to let me know either in person or on YouTube. Thanks a lot. Take care.